Hello.
Good evening, sir.
Yeah, good evening. Okay, we'll finish the last topic for matrices, which is solving systems of linear equations using matrices. So basically the idea here is if you have n linear equations in n unknowns, they can be written like this. Let's say these are my equations is equal to b1. Similarly, a21 x1 plus a2 x2 a2n xn is b2, and like this there are n equations, so it will be a n1 x1. So here there are n equations, the variables are x1 x2 till xn, and the coefficients are a11 a12 a1 until ann, and on the
Yeah,
right hand side it is equal to this b1 b2 bn. So this equation can be easily represented, this system of equations can be represented using matrices. And you can write A times X is equal to B, where A is your n cross n matrix of coefficients. This is your A. X is your column vector with variables x1, x2, xn. And B is the right hand side column vector with b1, b2 till bn. You can see that since it is n cross n and n cross 1, the multiplication is defined and it will give us an n cross 1 result.
yeah,
So we want to find out our x column vector, which is the unknowns in this equation. And that is what we'll learn how to solve using matrices. So first of all, this equation can be of two kinds. Ax is equal to b. It is non-homogeneous if your b vector is not a zero vector.
yeah,
Non-homogeneous set if b is not equal to 0 0 0 0, and it is homogeneous if b is equal to a zero vector on this side. So these are the two types of equations that you might see, and in any case, as long as your a vector is non-singular, if a is non-singular, then a inverse is defined. A inverse is defined, and what you get is a inverse a x is a inverse b. Therefore x is equal to a inverse b. Therefore x can be written as adjoint of a divided by det of a times b.
yes, yeah,
So that becomes your solution for the system of equations. The solution is valid if a is non-singular, right?
yes, yeah,
Now what we have is, if we have a non-homogeneous system of equations, we will see the properties. So non-homogeneous system. So the first thing here is, if a is det of a is not equal to 0, then the system of equations is consistent and has a unique solution. Det of a is not equal to 0, and non-homogeneous system means basically b is not equal to 0 matrix. So
yeah,
in that case, if a is not equal to 0, it has consistent, it is called a consistent system because it has a unique solution, and the unique solution is x is equal to a inverse b. right?
Yes.
Now, in this case only, if det of A is 0, if det of A is equal to 0 and adjoint of A, adjoint of A times B is not equal to 0, adjoint of A times B is not equal to 0, then the system is inconsistent and has no solution, and has no solution. Why is that? Because we can say that AX was equal to B, and we can pre-multiply with adjoint of
Yeah.
AX is equal to adjoint of B. We cannot write an inverse because that is 0, right? So
Yeah.
I'm going to write it like this, and we know the property that this is equal to det of A times IN, right?
Yeah. So even that has to be equal to 0.
So left hand side is coming 0 because of this condition, but right hand side we are saying is not 0.
Yeah.
So that's why there is an inconsistency here, right?
Yes.
So the condition for no solution and inconsistent system of equations is that is 0, but adjoint A times B is not 0,
Yeah.
right? And the third case is if that is 0, if that is 0 and adjoint A times B is also 0, then the system is consistent. Both sides are becoming 0, and then the number of solutions is infinite. Number of solutions is infinite. It is technically what is happening is both sides are identically 0.
Yeah.
So identically 0, then there will be infinite solutions. When we see
Yes.
examples, you will realize why that is happening. But you have to just look at these three as the main conditions. These three are the separate cases with which we can analyze a system of equations which are non-homogeneous. This is a consistent system with a unique solution.
Yeah.
Here the solutions are not infinite, there is only one solution here.
Yes.
And this is the case with zero solutions, no solutions, and this is the case with infinite solutions when both sides are identically zero,
Got it. Yeah.
right? Okay. Then we will also see the situation where when the system of equations is homogeneous. So let's take the case of homogeneous system of equations In this case, the matrix B is a zero matrix or zero column vector. So obviously 0, 0, 0, 0 will always satisfy a homogeneous system, right?
Yeah.
Anytime you have Ax is equal to B, but B is a zero vector, X could also be a zero column vector.
Yes. Yeah.
So that is a guaranteed solution and it is known as the trivial solution.
Okay. Yeah.
That is a trivial solution to the equation which is homogeneous, because obviously no matter what kind of equation you make, that is always going to be a solution. We are going to look for other types of solutions other than this also, right?
Okay. Yeah.
So here the case one is if det of A is not equal to 0. If det of A is not equal to 0, then the
X
system
has
has
trivial.
then
Yeah.
system has only trivial solution. Only the trivial solution. Why? Because X was A inverse B, but B is 0. So nothing. There is only 0 there.
Yeah.
A inverse B is defined, and but the problem is that B is 0. So always the solution comes as only the trivial solution, right?
Yeah.
This is the first case. Then, and here we will say that there is one solution which is trivial solution. Then the second case is if det A is 0 and in that case, the system of equations has non-trivial solutions and it has infinite solutions. Then the system of equations has infinite solutions. It is becoming like an identity in this case. If data is also zero, it is identically both sides become zero because you can say ax is b and det of a is zero, then x can be anything, right?
Yeah.
Like because you
Or you
can
could
say
say
uh,
the A inverse thing.
A inverse thing. If you say no, you cannot say A
Non-defined.
inverse.
Like you'll have.
Cannot use A inverse if that is zero.
Yeah, that's true.
We can say that det of ax is det of b, and this is zero, and we know det of a times det of x is zero, but det of a
Yeah.
is given as zero, so det of x can be anything.
Yeah, that's right.
Det of x can be anything. That gives
But
us a hint
X,
why it has infinite solutions,
but X is a column. What do you call matrix, right? So it can't have det.
right? Uh, okay. So if det of a is zero, let's multiply by adjoint. We are getting det of a in x is equal to adjoint a times b.
Yeah.
So we are getting det of a x is equal to adjoint a times b. But b is a zero matrix. So this is zero.
Yeah, that's why X has infinite. Okay.
Uh, Det of a times x is zero.
And det of A is zero, so X can be anything.
X can be anything because this side is also identically zero. Right. So that is the reason you multiply by adjoint and you can see that both sides are identically zero.
Yeah.
And the third case is if number of equations is less than the number of unknowns. Number of equations is less than number of unknowns. Then the system will have a non-trivial solution. Then the system has a non-trivial solution. So only case for non-trivial solution is if the number of equations is less than number of unknowns. You cannot write it as ax is equal to b in this case
Yeah.
because the degree will be different. Number of unknowns is bigger and number of equations is smaller, right?
Yeah.
So, however, as long as the equations are all homogeneous and this situation happens, there will be some non-trivial solution. So we'll see
Okay.
examples where this happens. Most importantly are the cases for the previous case when we are discussing non-homogeneous equations. And the more you do questions here, the better you will understand what is going on. So we'll look at some examples. So first one is this one. Solve the system of equations x plus 2y plus 3z equals 1, 2x plus 3y plus 2z equals 2, and 3x plus 3y plus 4z equals 1. Solve this system of equations by the methods that we have just now discussed.
Okay, yeah.
1 second, hold on. This is a non-homogeneous system. You have to do it by the methods
Yeah,
we have learned.
yeah, I'm doing that. Yeah. Oh, right. This is 3C. Yeah, the system is consistent. I'm just trying to get the solutions.
It's case 1 of the non-homogeneous situation, right?
Yeah, it's case one. Inverse.
Are you getting the solution?
Yes, I'm on the second one. I got the solution.
What is the solution?
Um, Not too sure, but I got 3 by 7, minus 8 by 7, and 2 by 7.
Not too sure. Why are you not too sure?
I didn't substitute and check once again.
Your solutions are numerically right and the sign is wrong.
Sign is wrong. Okay.
It is not allowed to make mistakes in calculations here.
Yeah.
Why are you in such a rush that you are getting the wrong answer? Minus 3 by 7, 8 by 7, and minus 2 by 7.
Oh, yeah.
Do the next three without any errors.
Yeah. I'll.
There is no scope for calculation mistakes in these questions. You have to follow a standard technique and you have to get the right answer. You cannot do it twice in the exam.
Yeah. I don't. I won't do it. Yeah.
You have around 7 8 minutes to find the answers for the next three.
Yeah. The second one is inconsistent.
Are you getting the second one?
Yes or no solution.
Second one, set of A is 0, and why are you saying no solution?
Because adjoint of A into B is not 0.
It is 0.
Oh, I'm.
What is adjoint of A for you?
What? Yeah, I got it as 2 minus 4, 2 in the column, and minus 3, 6 minus 3, and 1 minus 2, 1.
What happens when you multiply it with B?
I multiplied it with 6, 14, and 30, and you get 12 minus 42 plus 30. Yeah, 30, 60. Oh, never mind, it's 0. My z's value didn't come as 0.
It is coming as 0.
Yeah, it is.
It is
There are,
consistent.
but yeah, there are infinite solutions.
For infinite solutions, the way you find solutions is when you get that it is infinite solution, you can take Z as
Um,
anything,
okay.
take Z as K,
Yeah.
then you would get x plus y is 6 minus K, and x plus 2y is 14 minus 3K. And if you subtract, you get y is equal to 14 minus 3K minus this, so
Yeah.
8 minus 2K. So y is 8 minus 2K, so x will be 6 minus K minus 8 plus 2K. So x will be K minus 2.
Yes.
So any solution of the form K minus 2, 8 minus 2K, and K will be fitting the equation
Okay. Yeah.
where K is a real number, anything. But in
Okay.
order to realize this, you have to first check which case it falls under. That is 0, adjoint of A times B is also 0. If you
Yeah.
make a mistake in this, then obviously everything is wrong.
Yeah.
If both are 0, the system is consistent and has infinite solutions, and then you can find this.
Yeah, that's right. Um, so for the third one, it's again the same, infinite and infinite solutions.
Why is it infinite solution? Third one.
Because adjoint of A into B is 0.
Third
And
one
that
is
of,
the homogeneous system.
yeah, and that of A is also 0.
In that, you don't have to calculate adjoint of A into B is 0 for third one. Why are you doing unnecessary work?
No, I didn't calculate it. I just calculated the depth value, and we already know that what do you call B is a null matrix. So I didn't calculate that.
You have to just say homogeneous and det of A is 0, so it has infinite
Oh,
solutions.
yeah. I didn't calculate adjoint of A into B.
But you are saying that.
I just mentioned it because if basically meant homogeneous only.
What are the possible solutions for this if it is infinite solutions?
Yeah, so you can take any value of z or x,
Take
and
it
you
and
can,
tell me the possible solutions.
yeah, okay, I'll just do that one. Yes, so I got the values. I took x as k and I got the values as k, 8k, and then minus 4k by 5 and minus 7k by 10.
Okay.
Yeah, I'll just do the last one. The next one is inconsistent.
That is not equal to 0.
Yeah,
And it is a homogeneous system. In that you only have to check the debt.
yeah.
Okay. Next question is this one. The equations are x plus y plus z is equal to 6. X plus 2y plus 3z is 14. No, not 14. This is 10. And the next one is x plus 2y plus lambda z is equal to mu. You have to find values of lambda and mu such that part 1 is the system has no solution. Part 2, the system has unique solutions. Part 3, it has infinite solutions. You have to remember all your situations for non-homogeneous equations.
Yeah.
For no solution, what is the condition?
Like debt is equal to 0, but b is not 0.
That's wrong. Please say the correct condition. B is anyway not 0. What are you talking about?
Yeah, I'm
It's a
yeah.
non-homogeneous situation.
Yeah, for that b is not 0 anyways, and debt of a is equal to 0.
You did not write down what I wrote earlier, all the cases.
No, I wrote it.
So why are you saying incorrect thing again and again?
I Yes, so like for non-homogeneous system, we had debt of a is not 0, and what do you call adjoint of a into b is equal to 0.
Were you saying that right now?
No, I didn't mention the case properly.
Do you think the condition that I should write is debt is not equal to 0 and B is equal to 0? That is the condition.
No, it's adjoint of a into b.
What is the condition for no solution in a non-homogeneous system?
Yeah, the condition is that debt of a is equal to 0, but adjoint of a into b is not equal to 0. That's I said.
What is the condition for unique solution?
Yeah, so for unique solutions, det A is not equal to 0. Yeah,
What is the situation for infinite sum?
like both are 0. Det A and adjoint of A into B. I'll just do that. Det A is yes, so I got it. I got this. Uh,
What are you
I
getting?
got I got the value of lambda as 9 in the first case. And for the value of mu, I only got what it should not be equal to. Like,
What should it not be equal?
it should not be equal to 10, 22, or 2. And 2, sorry.
Lambda is incorrect. Why are you making mistakes in lambda? It is obvious that det of A is 2 lambda minus 6.
Yeah, minus lambda minus 3 plus 0. Yeah, I made a mistake. Yeah, it's supposed to be 3. So, sir, for mu, we'll only get the cases of what it's not equal to, right? Like,
You will not get multiple value. That mu is not equal to only a single value.
yeah, maybe because my lambda's value was incorrect, I got multiple values for mu.
Do it correctly.
Yeah, I minus 30 plus mu. Mu not equal to no, 0, 2, 20. Yes, sir, mu not equal to 10. I and and for the second and third, it is again only lambda for the second one, and third is infinite. So
You are getting a constant mu not equal to 10 in the first place.
yeah,
Getting lambda is 3, mu not equal to 10.
yes,
What is the situation for second case?
it's just lambda not equal to 3.
Mu can be any real number.
Yeah, that's right.
What is the situation for third case?
Lambda equal to 3 and mu equal to 10. Sorry. Yeah, that's right.
Did you find the adjoint of A value as this one?
Yes, I got the same value.
Are you using the faster method or are you using the cofactor transpose method?
I used the faster one this time.
You need to know all your conditions for non-homogeneous and homogeneous matrix. If you know the conditions, the questions are super easy.
Yeah,
The next thing is some special matrices like reflection matrices. So what we want is a matrix that given any point x1, y1, I should get the reflection of that x1 dash, y1 dash reflection about, let's say, x-axis. What is the matrix that will give me the image of the point after reflection about x-axis? So what the way we write it is we want to say that final value after reflection should be equal to some matrix here times the initial coordinates.
yeah,
This is an unknown matrix ABCD. So anyway, it is obvious that after reflection about x-axis, x1 will be equal to x1 dash, but y1 dash will be equal to minus y1, right?
yeah,
So from there, using this information, we can figure out what is ABCD, right?
yes.
So you can check yourself that the matrix 1 0 0 minus 1, this matrix when multiplied with the initial coordinates should give you x1 remains same, x1
Yeah.
plus 0, and y1 becomes negative.
Yeah, minus 5 1.
So this is your reflection about the x-axis, this matrix, right?
Yeah.
Similarly, you can do reflection about y-axis, and that matrix will be, find the reflection about y-axis matrix.
Yeah. Yes, sir. So it's going to be 1 0 0 minus 1.
No, it will be minus 0 0 1. Why are you doing 1 0 0 1?
Yeah, it's
If you are reflecting about y-axis, the x coordinate gets negative and y coordinate remains same.
yeah.
Why are you getting the wrong matrix?
I accidentally multiplied the modified value with ABCD.
You have to multiply or operate a matrix on the original coordinates, not on the
Yeah, I don't
modified.
know. Yeah, I accidentally did it on the modified one.
Reflection about y-axis matrix is minus 1 0 0 1. Reflection about x-axis matrix was basically 1 0 0
One.
minus 1.
Yeah.
Similarly, reflection about origin, you can prove that the matrix for this will come
Yeah.
out to be minus 1 0 0 minus 1,
Yeah, that's right.
because both x and y have to be reversed.
Yes. Yeah.
Similarly, reflection about the line y is equal to x. Reflection about y is equal to x line. In that case, the matrix that you need to have is 0 1 1 0, because if you multiply 0 1 1 0 with any initial coordinates, you will end up with yx.
Yeah.
Do you understand what is happening?
Yes, sir. Yeah.
This is the initial coordinates. If you multiply with this matrix, you will get a final coordinate which is reversed.
Yeah, YX.
And lastly, reflection about the line y is equal to x tan theta. This is a line making an angle with slope theta, tan theta line. You want to find the reflection. What matrix should you apply to get the reflection in this case? So
Yeah.
obviously first you will have to find the point x dash y dash by normal coordinate geometry methods.
Yeah, that's right.
Only and if you find the point, then only you can write an equation which will give you a matrix equation like this, which should give you, after multiplying the matrix, you should get x dash y dash.
Hmm. Yeah.
This is not a difficult calculation. You know how to do reflection about a line, right?
Yeah.
You have to think of this point as the midpoint, and this is perpendicular bisector. So the midpoint
Yeah.
lies on y is equal to x tan theta.
Yeah. So we know the slope.
So finally, you can prove that the required matrix will come out to be cos 2 theta, sin 2 theta, cos 2 theta, sin 2 theta, sin 2 theta minus cos 2 theta. This is the reflection matrix which will help you reflect a point about a random line through the origin.
Hmm. Yeah.
This is homework, prove it.
Okay. Yeah.
It is not difficult to prove, you just have to find it.
Yeah.
Make sure you do that because sometimes there will be questions where multiple transformations are being done on a point, and finally you have to find after all of those transformations the image of the point.
Okay, that's right. Yeah.
So if you are doing two, three operations simultaneously, you can do, okay, I reflected about this, then I reflected about y-axis, then I reflected about x-axis. All of it is just a multiplication of all of the reflection matrices.
Okay.
Suppose they are three, this is Rx, this is Ry, this is reflection about y is equal to mx. And
Yes.
this was your initial point xy.
Yeah.
Ultimately, you will get the final point x dash y dash after it has been worked upon by all of these matrices.
Okay. Yeah.
So first you will apply this, then you will apply this, then you will apply this. But the effect of that will be same as the product of these matrices.
Okay.
If you find the product of Rx, Ry and this matrix that we just now saw,
Yeah. Yeah.
then
And we,
the overall matrix is what gives you the final transformation.
or can we try finding it using the y is equal to x thing is because we know in this case that tan theta is one. Can we like try relating the two?
What are you talking about, right?
Like in the previous question, we found out about the reflection about y is equal to x, which is similar to y is equal to x tan theta, but in this case, tan theta is 1. So maybe we can try relating the two and finding out in terms of theta.
That will just give you for one line. This is a general result for all
Yeah.
lines. You are unable to find the reflection about y is equal to x tan theta line.
No, you are. You have to do the midpoint and
So why are you not able to? I mean, what is the problem in actually doing it and proving that this is correct?
no, there's
Instead
no
of
problem.
taking instead of taking special cases, why can't you do the actual thing?
Yeah, we can do even that.
Do you think just by verifying it for tan theta is equal to 1, this is proved?
No, it's not just by that.
That is just one particular line. What is the benefit of that?
Yeah,
This is in general for all lines passing through the origin.
yeah, that's right.
But I was talking about something else and you're asking something else now. What was I talking about right now?
Yeah, I understood. Like you told me to like find it as a sum of reflection about x-axis, y-axis, and some other thing which will sum up to y is equal to mx.
You have totally missed the point because you're not paying attention. I was not talking about this y is equal to mx thing. I was talking about in a question, you could have a situation where your point has gone through multiple transformations. It is possible that they might say that the point has gone through a transformation about this line, reflection about this line, then reflection about y-axis, then reflection about x-axis, and finally you get a point x dash y dash.
Okay.
This is not an explanation of how to prove the previous thing.
Yeah, that's just an example. Okay.
If you have a situation like that, you need to know your matrix here, cos 2 theta, sine 2 theta. You need to know your transformation matrix here, and then you need to multiply that with all the other matrices that you have found. You know,
Yeah.
reflection about y-axis and reflection about x-axis, the two matrices, and the overall effect. In order to find the final position, it's the same as if you multiply all of these three matrices, you will get a final matrix, some x, y, z, w, which has to be multiplied with x, y.
Yeah.
Do you understand what I'm saying right now?
Yes, sir. Yeah, I got it.
If there are three different transformations happening, then it's like three different matrices being multiplied, and overall effect is what is going to happen to this point.
Yeah.
And obviously here order matters. It is different. A, B, C product is different from C, B, A.
Okay. Yeah.
The matrices don't have to be commutative and all. So
Okay.
depends on, you have to be careful about the order in which you do the operations. If the first transformation was the reflection about y is equal to mx, you have to put this matrix first.
Yeah, I got that.
And then you have to put the other matrix, which is the second operation, and then the final matrix.
Hmm. Yeah.
The proof of the reflection about y is equal to x, mx matrix, you have to do by doing the general method, not by doing special cases.
Yeah.
That finishes the theory for this chapter. Now you have to solve your JE advanced questions and see whether you're able to do it or not. Everything that is required has been covered.
Yeah. I have begun PYQs for physics, but I have to begin it for math as well. But we did have JE advanced PYQs in the module which I could get. Yeah. I was able to solve them.
Okay, that's all for now. We'll do problems in the next class.
Yeah. Thank you, sir.